So I went out to my shop to use my Powermatic wood turning lathe, but it wouldn't work. No matter how I turned the controls, it just sat there doing nothing. I hadn't used it in several weeks, so it probably wasn't mechanical trouble, and besides, the spindle turned freely by hand. It was most likely an electrical problem. It was getting power because the numbers in the digital tachometer were on, although they stayed stubbornly on zero. The motor itself was an unlikely suspect. When motors die, it's usually with a lot of smoke and fire and screaming. Now, a lathe is a dead simple tool with nothing but a motor spinning a chuck, and the only complicated thing on it was the electronic speed control, and it was pretty obvious that mine had failed. So I started poking around on the lathe to see if there was any way to fix it. The speed control on my lathe is a VFD, or variable frequency drive, which is basically a digital computer with some humongous power transistors. Mine runs on 240 AC volts, the same as your dryer or electric cooktop. But the actual motor on my lathe runs on three-phase electricity. That's the magic of the VFD. It takes in single-phase AC, converts it to DC, slices and dices it up every millionth of a second, and then spits it out as three-phase AC. Smooth, steady three-phase. The first resource I checked was the original manual, where I identified the correct part number. Armed with that, the Powermatic website informed me that I could replace the VFD for a mere $650, FOB Laverne, Tennessee. Another website that specializes in replacement parts wanted about the same, and the price tag made my eyes water. So, I kept working on the dead VFD, taking it apart and jotting notes about how it was connected, taking pictures of the wiring. At the same time, I continued doing web research, trying to find out as much information as I could on VFDs and how difficult it would be to replace my dead one. Now, one of the strange quirks of this lathe is that it lacks any kind of main electrical power switch. Yes, it has an on-off switch, but that controls power to the motor, not to the motor controller. So while the motor only ran when I wanted it to, the electronics stayed on night and day. Night and day for the entire 10 years I've owned this lathe. No wonder it died. Now, in defense of Powermatic, I get the impression that VFDs don't like to be turned on and off very often, so that was likely their rationale for not including a main power switch. I expect they were worried that people would depower the VFD instead of just stopping the spindle motor. But I decided it was time to add a master power on-off switch to the lathe. With normal 120 volt wiring, you only need to put a switch in line with the black wire, or the hot leg of the circuit. Now with 240 volts, you need to switch both the black wire and the white wire, as they both carry electrical potential. You don't need to, but it's good, safe practice. All you need is a double pole, single throw switch. That is, the switch only has two positions, on and off, but it has two separate circuits inside it that can connect and disconnect the two wires in tandem. I used a little waterproof plastic junction box with two waterproof cable fittings called glands, one for the incoming power and one for the power out to the lathe. Now, there are many advantages to having a machine tool with a VFD. For one, you can get very precise control of the motor's speed and over a wide range. It's relatively gentle to the motor, and it can adjust for varying loads, so once you set a speed, it holds it no matter how hard you work it. These characteristics are desirable in most every machine tool, but they're very useful in a wood-turning lathe. The other significant advantage of a VFD is that the actual motor that turns the spindle is a three-phase motor. And three-phase motors are much more powerful, more efficient, and far happier than single-phase motors. They start faster and stronger, they run cooler and smoother than single-phase motors. Most all industrial machines run on three-phase power, so the electric company supplies it to factories and big machine shops. Unfortunately, houses are rarely supplied with it, so having a machine tool that can synthesize its own three-phase is a good thing for hobbyists. Now, there are other ways to synthesize three-phase from single-phase using electromechanical methods, but they waste power, produce unequal phases, they're loud and hot, prone to failure, and they're expensive. Now, VFDs, being digital, are only getting cheaper and more powerful. So I did more web research on VFDs. It turns out that you can buy a 2-horsepower model for as little as $130. The problem is that they come from shady-looking companies and they lack any documentation or support. More reputable ones cost about $230. I thought that was a price I could afford if I could wire and program it correctly. You see, because it's actually a powerful digital computer, every VFD is capable of being configured into a near infinite range of custom motor drivers. All you have to do is understand the 200 or so cryptic parameters designed by electrical engineers for electrical engineers with an interface designed by, you guessed it, electrical engineers. I began to search YouTube for how-to videos, and it didn't take me long to find Clow42 and his 2-part video on adding a VFD to his metal cutting lathe. He patiently explained all the little tiny details that I needed to understand to have the confidence to make this repair. After that, it seemed like a pretty straightforward replacement job. Except for one thing. I needed to know the actual parameters my particular lathe's motor needed so that I could program the new VFD. So I figured, what the hell, and I telephoned Powermatic's tech support. After establishing that there were no hidden gotchas in replacing the VFD, I broached the topic of using a cheaper model direct from China. The tech guy was only a little surprised, and he said that he didn't see any reason why it wouldn't work. I then explained that I would need to get the exact parameters from Powermatic. Without hesitation, he emailed them to me. Now I was ready to go. My plan was to buy a VFD similar to the original, getting the specs as close as I could. I would then have to adapt the old wiring harness to the new VFD and then translate the parameters to those needed by the new unit. I figured this would be difficult, but not impossible. At this point, the fog in my brain cleared, and I realized that I had been overlooking something simple, obvious, and important. The stock VFD on my lathe was encased in a plastic housing, which I had assumed was made by Powermatic to hold the electronics made by another manufacturer. So I had ignored the external markings to focus on the internal ones, and that was a big oversight. I finally realized that the housing itself was an integral part of the VFD, and the data plate on the top of the housing contained vital information. Duh. The data plate told me the unit came from Delta Electronics, and it was a VFD015S21U. Instead of searching for equivalent specs, I now searched on the precise part number. And I immediately located a half a dozen companies who would sell me the identical part for as low as $230. I bought a brand new one from a company named Galco. It came in about 8 days, direct from Taiwan, but with support and documentation from the USA. Using the exact same part meant that the replacement would fit the old mounting holes, and I wouldn't have to fabricate a new mounting. It meant that I could use the original wiring harness to connect up the new one without any extra splicing, and I wouldn't have to translate the programming instructions. It made things much easier than I expected. The hardest part of the install was reattaching the wires to the new VFD. There was room for everything to fit, obviously, but the wires were crammed in there pretty tight. With the power switch box all wired up, I could attach it to the lathe. Long ago, I had added a little wooden shelf to my lathe, so I screwed the switch box to its underside with the switch facing forward. It's easy to see and reach there, but it's out of the way in normal use. Next came the smoke test, where you plug your stuff in for the first time. You ready? Puppy powered up. My wiring job survived the smoke test. Now, with the hardware working, it was time to program in the appropriate parameters. Actually, it sort of works with no changes at all to the stock settings, and it required remarkably few custom settings. I only had to key in 14 of them. Mainly, it was minimum and maximum output frequency and voltage, and settings for motor acceleration and deceleration rates. To my relief, it turned out that the buttonology was nowhere near as difficult as I had feared. Now it's time for the real test, turning some wood. Here's an old piece of California bay laurel. Out here in the country, the old-timers call it pepperwood. This chunk has been drying in my shop for a few years, so it's hard and cantankerous, and it has some rotted places too. I'll have to work around them. It's not going to make a great bowl, but it's a fine test piece. Hey, I just heard from my neighbor Jeff. He said he can get me some fresh cut rounds of pepperwood, and I'll make a video showing how I rough turn green wood. Thanks for watching.